Keep a permanent copy, you have to store it on the storage disk. And let me turn my little camera back on here. I have some examples. This first one I'll show you is from 1985. This is taken apart. I took the cover off of it when it crashed. And it's a 20 megabyte hard drive. Okay, had 2 discs and weighs about 5 pounds. Okay, so it's 20 megabytes. And we really, when this came out, I can remember we thought, oh God, that's ridiculous. 20 megabytes. Oh my God, what do we need that for? That's a lot of memory. We'll never fill that up. 20 million bytes, and it's very noisy. Okay, and then about 10 years later or so, this is I think a 6 gigabyte hard drive. Got smaller, more, it's more compact, got more data on it. And of course now they've got them, the size of a postage stamp, little hard drives that have like 10 gigabytes on them. Okay, of course then there's the old floppy disk media. Everybody knows by now what a USB looks like, but this is actual where the name floppy disk comes from. It's floppy, if you've ever heard floppy disk. And it's floppy inside of here too. It has a little hard cover. This is 1.44 megabytes. So it has a little floppy media on it. Okay, so it's coated with metal oxide, and the hard drive system or floppy drive system would energize that plus or minus voltages and raise and lower the fibers of oxide, metal oxide on the surface. Turn them into ones and zeros is the way it was reading it. Plus and minus voltages or magnetism. It's kind of crazy how it works. And still, your hard drives that you buy today use that same technology. That has not been changed for hard drives. Okay? So data is stored in tracks in a special log and on the disk called in a file allocation table, or the FAT. Then we have removable disk, magnetic media, rarely used anymore. What I was just showing you, 3.5-inch disk and zip disk. Optical storage is becoming less and less as well. We have all the cloud storage systems now, but those are available where you can burn the CDs and burn the DVDs and store, up into near the gigabyte range. Then the solid state media is coming on strong. Solid state hard drives, and of course portable USBs and all kinds of flash drives we call it, but they're all solid state, no moving parts. You actually program in the data into it, saves into it, and stays pretty much permanent unless you run it through the washing machine or dryer, or run over it, get it close to the back of a speaker, or leave it on the dash of your car, different things like that. Then network drives, hard drive or tape drive connected to a network server. There are still some tape backups out there, probably by the federal government, but a hard drive could be used and usually used like our server. Remote storage, which would be sent out over the internet and could be called the cloud type of storage, like your iCloud, your Google Drive, Dropbox, any others anybody heard of? Cloud storage. Okay, so you got to keep it away from magnetics. DVDs, hold them at the edges. Never remove media from a drive when the indicator light is on. You should always click on the eject to safely remove hardware, and the reason for that is it's energized and you create a spark, although very small. It's only like 5 volts DC, but pretty good amperage, and you create a little spark in there, and that can jumble something. Okay, happens rarely, but it can happen, and if it jumbles the right thing, it's useless. There is no recovery possible. Okay, just want to spin the bucks. So, in looking into the future, the ability to connect with other computers keeps increasing. Computers with computers, our wireless and mobile devices are, they're common as wired desktop machines, and taking over those, your laptops or your notebooks like the MacBook, still very popular. Where it's going from there, I don't really know. It would be hard to imagine, somebody 50 years ago in 1964 saying, in 2014, everybody would have the ability to communicate and to have a video phone capabilities in your hand. We couldn't imagine it, I can remember, say, 64, I would have been 10, so I think maybe when I was 11 or 12 doing a science report, and still remember I made and still have it. And it was about being able to communicate and read your newspaper electronically. That you'd have an electronic newspaper. So 50 years ago, they were talking about it then. And of course, video phone. That was all the thing. Oh my gosh, to be able to have your own personal video phone. So, some of it was thought of back then. So, computer literacy, which is the knowledge of understanding and knowing the computers like you're learning today, having that in your background as a technician, as a member of society, being able to know about computers and staying up with them, it's so much a part of all of our society. We need to know as much as we can learn about them. So we learned a computer is an electronic device, receives data, processes data, produces information, stores the data and information that we instruct it to. Computer derives its power from speed, reliability, accuracy, storage, and communications capability. Computer classifications include your personal computer or general, mobile devices, servers, mainframes, supercomputers. All computers perform the same general functions: input, process, output, storage. All grouped together makes a computer. The machine cycle is made up of the instruction cycle and the execution cycle. ALU, arithmetic, logic, unit, and storage. Motherboard, that's the center of all processing. Memory and basic controllers. It contains the ports and expansion slots for mainly your desktop tower kind of units. There's a few on the current, there's some limited connectability on some of the new desktop units that don't really have a separate unit. You can still buy those towers and customize them. The motherboard contains several types of memory. RAM is volatile. ROM is non-volatile. And the CPU is the brains. Has 2 sections, your ALU and the control unit. To maintain a permanent copy of data, you should store it on some type of storage medium. So magnetic, optical, and solid state. Right now, optical storage is on the wane, but it is, tends to last a long time. The magnetic storage, again, is susceptible to magnetic fields, and also to, we're also always being bombarded with some cosmic rays from outer space. You know, there's cosmic gamma ray and so forth, so they're not permanent. And that stuff, you know, it goes completely through the earth. You know, it's very strong, very powerful, very weak, so it doesn't last. This is the magnetic fields. It doesn't last forever. It lasts a very long time. Optical storage, the data is inside of the CD or DVD. There's actually a metal. You know, have you ever taken one completely apart, busted it open, tried to peel it apart? You know, it's actually metal. It's a piece of metal inside of the CD or DVD. Okay? And the laser in the drive burns an equivalent of 0, 1 information, gaps, okay? And burns into it. That's why after you record something on a CD or DVD and look at it, you can kind of tell, oh, right here it is. Here's where my data is. It's a little different shininess, a little different color even, okay? Then it's got plastic coatings on the outside of it. So it's pretty permanent, you know, 100 years, something like that. And then if you put it in deep storage, you know, it can last even longer. Put it inside of lead containers or whatever. The magnetic storage tapes, don't know how long they'll last. They last a long time, but again, they're susceptible unless they're kept in a controlled, temperature-controlled environment. That acetate that it's on can become brittle, and then the magnetic fields that might be present can change the data. Okay.